What's up guys, Major Math with another video on fluid mechanics. If you have any questions, drop it in the comments, and if you're having trouble with other problems, I've attached my email in the description, so please feel free to reach out. Without further ado, let's get started. Question 1.9 in the textbook says water is flowing in a metal pipe. The pipe outside diameter is 61 centimeters. The pipe length is 120 meters. The pipe wall thickness is 0.9 centimeters. The water density is 1 kilogram per liter. The empty weight of the metal pipe is 2,500 newtons per meter. In kilonewtons, what is the total weight pipe plus water? So with every single fluids question and problem, you're going to want to do write your goal, write down your givens, and write down what you're assuming. For the goal of this question, you're trying to find the total weight, so the weight of the pipe and the weight plus the water. So I wrote this little formula. So that's our goal. Our givens, we're given the outside diameter, the length of the pipe, the thickness of the pipe, the density of the water inside the pipe, and the pipe weight with a distance per distance. We're going to be assuming that the water is incompressible. All that means is that the density is just consistent throughout. So wherever if I were to take a sample of water from anywhere in the pipe, it's going to be that density of 1 kilogram per liter. That's all that means. And then the other one is that this is going to be important later to find the volume of the water inside the pipe. We got to assume that the water fills the pipe completely. There's no air pockets. Okay, so the next step after we do this is figure out what equations we need. So we're obviously going to need the weight equation because we have to find the weight of the water and the weight of the pipe. So for this, weight equals mass times an accelerant, and in this case the only accelerant will be gravity. So that weight equals mass times gravity. We're also going to need to know the density formula. Density, we know the density formula is density equals mass over volume. I'm going to go ahead and rearrange this to mass equals volume times density because we're given the density. The unknown here is mass, right? Because we're got to solve for this. We want to solve for the weight of the water. We're going to have to solve for this mass. This is what's unknown here. So how do we solve for the mass? We got to use this density equation. So we got to solve for mass. So we know density, it's already given, and then we can solve for volume given using these variables: outside diameter, length of the pipe, and thickness. So this is what it looked like. Yeah, so weight water equals mg, right? We can also rearrange this because we know that mass is also equivalent from this density formula to volume times density. So we're going to rewrite this as volume times density times gravity. Okay. So now we know the density, we know the gravity, but we need to know what the volume of the water is. So to find the volume of the water, we're going to want to find the area of the cross section of the pipe and then multiply by the length of the pipe. So if you think about it, here's the pipe. If you did a cross section, this is what the pipe would look like, right? Because you got a thickness. These are T's for thickness, and then you got the outside diameter that goes across the whole entire pipe, and then you got this inner diameter, right, for the smaller circle right there. So if we want to find, this is where the water is going to be, right? This smaller pipe, this smaller circle. So if we want to find the volume of the water, we can actually take the area of this circle right here, where the water will fill it completely, get the area of that, and then multiply by the length of the pipe to get the whole volume of the water. So the area of this inner circle would be pi over 4 times the inner diameter squared. If we were using the radius, it would just be pi r squared, right? Or pi times the inner diameter or the inner radius squared. But since we're using diameter, we have to do pi over 4. And then we know that length, I've written it up top, is 120 meters. So to find the volume of the water inside the pipe, we will do pi over 4 times the inner diameter squared times the length. But we don't have the inner diameter squared, but we can solve that pretty easily here. So inner diameter will equal the outer diameter minus thickness twice, right? So you have this outer diameter that runs across, and then if you minus the thickness on both sides, you'll get this inner diameter. So that will just be 61 centimeters minus 2 times 0.9 centimeters. That's going to give us 59.2 centimeters, which if you convert that to meters, be 0.592 meters. Right. So now we have this inner diameter. We can go ahead and solve this. And this is going to equal 33.03 meters cubed, right? Alright, so we have the volume. So now when we have the volume of the water, we can solve for the weight of the water, which is what we're going to do this whole time. Let's go ahead and plug those numbers in. So we got volume of water equals 33 point. I'm going to give myself more space. Right. And then the density is 1 kilogram per liter. And the gravity is 9.81 meters per second squared. Okay, but we gotta convert. We gotta make these numbers match up. So if you look in the textbook and table F2, we know that 1 Newton equals kilogram times meters per second squared. And we also know that 1,000 liters equals 1 meter cubed. So using this, we can help get our units right, so we get the right number here. So we're going to multiply this by, I'm multiplying this equation is what I'm doing to convert the units. We'll do, so the liters on bottom, so we'll put liters on top here, cancel those out, we'll get 1 meter cubed on the bottom, times, we got to cancel out, so we got put this on the bottom, so that will cancel out this and cancel out this right here, and we got 1 Newton. This meters cubed will cancel out, and that will leave us with 324 about, if you round, newtons. And then it says the problem says it wants that kilonewtons, so you just divide that by 1,000, which is 324 kilonewtons. Okay, so we found the weight of the water. Now we find the weight of the pipe. So this one's pretty simple, just because of what the problem gives us. It gives us that this 2,500 newtons per meter. So for every meter of pipe, it will weigh 2,500 newtons. And we know that we have a length of 120 meters. So just doing 2,500 newtons per meter times that 120 meters will actually give us the weight of the pipe, which is 300,000 newtons, but then if you divide it by 1,000, will give us kilonewtons. And then from our goal, from the equation we made, we know that to find the weight total, we have to add these together, right? So this is the weight of the pipe, this is the weight of the water. So 324 kilonewtons plus 300 kilonewtons equals 624 kilonewtons, which equals the weight total. And that is our answer. Thanks for watching, soldiers. Don't forget to leave a like and subscribe for more content like this. If you have any questions, leave it on the comments, and if you need help with any other problems, feel free to contact me with the email shown on the screen.